The universe travels the path of entropy. The only way forward is chaos. What is up, YouTube? Chaos. Welcome back to episode 3 of the Draco RC build. We have an interesting day for you guys today. Quite an interesting video indeed. I was sitting there, as I do, doing my thing on CAD, CADing away like a CAD wizard that I am, thinking, what should the subject of episode 3 be? I had nothing. Blank. Zero. Zilch. Nada. Zip. And then I get a message. I get a message from a lovely gentleman called Matt. Hi, Matt. Yes. Let's have a look at what Matt had to say. Matt writes to me and he says, "Hi there, Chaos23. I recently watched your Draco 3 vid and I am quite impressed with the CAD ability and attention to detail you have to figure out these complex shapes." Thank you, Matt. That's really nice. I appreciate that. Just wondering if you have any idea on how to go about modeling the exhaust cover on an F82. Wow. Sure. I'll take a look at it. This is the closest I can get, but it feels totally lacking. The real deal has the cover where each outlet flows into the next, reducing drag. Yes. This is a fantastic attempt. This is the go-to approach for anyone that's new to CAD or not new to CAD, or is just that would have been my first approach. Try something like that, get it to blend. But clearly this and this are not the same thing. Like it's clear to see. So what is different with this? Let's see what else he had to say. I'm using SolidWorks. Yeah, you know, I won't hold it against you. To design this FDM part. Any thoughts would be greatly appreciated. Good luck on your Draco build. It looks amazing so far. Thank you, Matt. Thank you. Well, I wrote back to Matt, and I think I confused him. Well, he got 75% of it, so that was helpful. So I did some stuff, and I showed him how to go about it. It's not perfect. I can still see a number of things that I still didn't even get right, but it was enough that, well, he got it. Pretty close. It's the same as like mine. It's not perfect, but it is a lot better than his first attempt, and that looks amazing. So, awesome work, Matt. That's fantastic. So, let's have a look at how we work out what the shape of something is from a picture, because it's not easy, and quite often the pictures that we have aren't perfect to figure out what we want. So, how is it that you go about looking at something and working out its shape? I haven't really explained much about this process. I've done lots and lots of just showing you me getting dimensions of stuff, and that's easy enough. You just put the image there, you draw a line with the dimension on a thing that you know the dimension is of, and then go from there. You only use the dimensions of certain things in the image that are in the same plane of perspective and aren't parallaxed or lens blurred and stuff. Yeah, there's a lot to it, but it's pretty simple. But I haven't talked about finding shape, how to find geometry, how to find curves, work out how to then take what you see and create a method for creating a shape in CAD. CAD design, computer-aided design, is all about orders of operation. It's all about the method you use to approach the shape to get to what you want. And it's a big puzzle game. It's a bit like, you know, working out puzzles, and I love it. So I'm going to go through that with you and show you how I went about figuring out how to make that shape for Matt. Okie dokie. So let's have a look at this now. Right. When we want to find the shape of something, we need to look at certain identifiers, certain markers in an image that allow us to determine shape. The key things that our brains look for when we look for determining shape is light. How light plays off the object, where shadows fall, where highlights are, where things contrast. This delineates in our mind outlines and form, and then from that our brain develops the three-dimensional geometry of those markers. So when we look at an image, even when it's blurry and zoomed in like this, we can still see quite a bit of information. We know from the rest of the shape of the aircraft that it's pretty flat. We're looking straight on from it. There's very little play in the light, but we are seeing little spots of highlighted light from the lighting in the scene. So we know that the object we're looking at is fairly shiny, right? This is all simple stuff. But what shape is it? Well, because this is all pretty flat and the color and the highlights don't appear much, we know that this is a pretty soft curve, a pretty flat face. It's not entirely flat because we can see the way that there are some lines up here, which means that it curves a bit more. When lights play off of a curved surface, they generally make a line. When it's a cylindrical surface, it's a line. When it's a spherical surface where it has a compound curves in two directions, it is usually a spot or a point, or you get a bit of a fuzzy little area, depending on the shininess of the material or the shape of the curve. How intense the curve is determines how fine the point is. The finer the point, the sharper the curve. So, looking now at the rest of this, we need to try and determine more of the shape for these pipe covers. We can see here we have intense spotlight. This is probably from the flash of the camera. We can tell that there's been a flash because the shadow cast of this man and this gentleman here at the front against the aircraft behind him is pretty straight on with him. So we know that there's a flash on the camera. So from that we can determine that when we look at these highlights on these curves, we know which direction the light is coming from, and this helps infer in our minds the shape of the object. Because we've got this flash point on this flat area where there is a slight bit of a curve, and that's why we only see the point of the flash here and not spread out over the whole shape. We can still see that same flat at every single one of these points along here. So we know that the area just ahead of the underside of these pipes is flush with the surface of the aircraft. As for up here, we can see that this color gradient from this light gray to this dark gray is pretty much the same as the color gradient from this light gray to this dark gray. And we can infer that this curve has an apex point along here. However, the gray in this section here is much darker than the gray in these other sections. So we can infer that this section here has a much larger gradient, a much larger slope, because the gradient is getting darker further up as the slope curves away from the camera. We can say, right, so this must have a much larger slope to it. And that blends in now the top of these cylinders. We can also see that the shape of this cylinder, if we, in our lovely screenshot tool, start drawing some lines like I did for him when I took a screenshot and explained what's going on, you can see that there's a bit of a straight line that comes off of here, and it goes to the apex of this curved surface that comes and joins up here to the next one, and this is a repeating geometry. So if we infer that that line continues, we can follow that line to the back, and then same to this one. We can follow from the front here, the apex of the curve, to here. We can then draw a line that tells us that there should be a delineation between this surface here on the tops of these pipes and the surface that meets and blends with the rest of the aircraft. Other things that we can tell is that the same sort of thing is going on here. This crux of the corner in here, there seems to be, it's not quite a straight line, but you can infer that that's pretty much a straight line, which is a combination of the curve, the outside curve of this pipe here, and the inside curve of the opening here, which creates an S shape. So from that, we can say, okay, one of these things is created with a repeating geometry of this sort of shape, this sort of like yin and yang, but with the fat ends touching, if that makes any sense. So this is the profile of the shape that we want. We don't really want the pipe as he had in his first attempt. So now that we have the profile of this geometry, we then jump into Inventor. So in Inventor, we need to get a few things set up. First things first, we're going to create a sketch that's going to give us the surface of the aircraft. I've just made it a flat surface. The actual aircraft probably has a bit of a curve there, but to keep things simple, I just made a rectangle shape so that we can have a surface to play the aircraft, the pipes out of. Right. Next thing we need to know is the angle that the pipes are coming out of it. And if we look at those pipes, they are both coming out of the aircraft. And if we go now this is one of the terms that Matt had some trouble with. I'm going to give you guys a bit of geometry jargon here. If we say that this surface of the aircraft, this panel, if we draw a line down the middle of this line is called the longitudinal bisector. It's longitudinal because it runs the length of the rectangle, and it is a bisector because it cuts this section in half. Bisector. So we can see that these pipes come down, and obviously they come out from the face of the aircraft. But we can see that this is actually a very shallow angle, and it's also because the length of this shape from where it sticks out to where it blends with the aircraft is quite long. We know that the angle at which it comes out from this bisector is also quite shallow. So it's a shallow down and a shallow out. So from that, I just created a quick three-dimensional sketch. And here it is. You can see it sticking off the center of this rectangle. So we have the distance that this angle is coming away from the surface, the distance it's going down, and the distance that it's coming out. You can do this with angles instead. I just did it with this because in 3D sketches it's easier to use the distances in the 3 directions rather than setting up the angular arc seconds for each of the lines in the 3 different planes of orientation. It gets confusing when you're using 3D sketches. Once you've got that, the next step is to create that shape. So you can see here I extended it going in further than I needed it, and you've got the outside curve of the pipe and the inside curve of the pipe. Now you'll see that I've created it at a weird angle compared. It's not coming straight down with this rectangle, it's the other way. And this is because when you repeat this geometry along this axis, you want them to overlap in a certain way so that these faces meet. So the thing that you're trying to match up is not this line here, this axis of this geometry with the face of this geometry you're going to create, but you want to line up this corner here with this corner here along the z-axis in this case. Next up, you repeat your geometry and you see there how that makes now a nice flat plane. And then carrying on, creating the square, then we just use your fillet functions. Mine are broken because I was fiddling with it a bit more. But along down the ways, you get to a point where you end up with what you want. And there it is. It's really simple. It's just a matter of looking at the shape that you want, figuring out, okay, how do I make this? And that comes down to, like I said, you look at the image and you need to work out your cross-sectional profiles of your shapes. And that turned out to be that weird double teardrop, yin and yang smushed together sort of S-curve shape. And yeah, that's it. There are some things that are still not quite exactly right, because if you follow this S-curve, it comes down and meets up with the geometry of the aircraft, and then it looks like it comes and scoops into it. Whereas what both of us have done, there is no scoop there. That S-curve comes and it meets up at the back here rather than at the front here. So to make this better, I would bring this face further out, and then you create another piece of geometry that was like the one that we created to create this repeated geometry, but you do a negative of it flipped around so that it ends up creating a scoop out here, just a very small one on each one of these profiles, and I think just a little bit on this one. This one and this one, the ones on the ends are they're a bit different to the repeated geometry in the middle because they are the ends, so their geometry changes slightly, so they become the exception to the geometry you're trying to create. So if I wasn't being lazy and just trying to do this quickly, what I would have done is I would have created a repeated geometry for these center 4 ones, the 4 in the middle, and the ones on the end I would have created in a similar way, but slightly different, so that the one on the end blends to the end on that side, and the one on the other end blends to that one on that side. Because if we look at the image, on the image, there was more of a blend coming off this back one, where they sort of sloped more up like this, and the curve that it created was sort of like that sort of shape. And we're missing this sort of profile that was on it. And then that would have continued like so to that point there. And you would have had a fillet that kind of made that sort of shape. And that's what we're missing. So the method to create this is on the right track. This is the right way to go about it. It all depends on how much time and effort you want to sit and make tweaks and adjustments and fine details to tune it in so that it is exactly right. And this is good enough. For the FDM print, the amount of detail you lose with FDM printing pretty much means that this is your maximum level of detail. There's really not much point going further than this, because you're going to lose detail in the manufacturing process as it is, so you're wasting your time going further. And there you have it. It's not the best explanation in the world because I'm trying to keep things general. There are so many exceptions to rules. There are so many other little nuances to this kind of skill that I can't really get across in any kind of reasonable video. It's something you learn over years of just practice and trying things. So hopefully that was helpful, and it lets you guys look at your imagery, your reference imagery, and develop your shapes and geometry better. This will improve the look of your models. Keep in mind, whenever you're doing something, lay out your design criteria at the beginning, your parameters. You have to look at what is your manufacturing process, what are your limitations of your design parameters. That way you're not wasting time putting all this extra fine detail in something only for it to not show up or end up adversely affecting the surface finish of your product. With FDM printing, it's a win-lose situation. You get to be a bit more lazy. You don't have to put as much detail in because there's only a certain limitation on the detail that you can print. In my case, I'm using a resin printer, so I kind of have to go full balls with that detail. I don't get to say, well, you know, that's the limit of the manufacturing process. No, it'll do 5 microns, so that means rivets. All the rivets, screw heads, everything, I'm going to have to do it. It's going to drive me crazy. Yeah, so hopefully that was helpful. Before I go, let's jump into Inventor again, and I will show you where I'm at with the Draco build. I've gone quite a bit further. So let's go have a look at that. Oh yeah, this turkey's got some legs now. Isn't that cool? Let's just go over some things that I've noticed in getting these legs done. Things I'm not happy with and will ultimately leading to me redoing 90% of what you see. Minus the wings. The wings are cool. I'm happy with wings. The elevator's cool. Things that I still need to change. Well, if you look at it head on, she's a bit skinny. And I think there's a couple of things that play into this. I think it comes into the dimensions that I got for the height of the windshield. Is raising the front end up here to where the wings meet a little too high. I think it needs to come maybe half a thickness of the wing down a bit. Another thing that's playing into it is the lower end of the front cowling. I think I have it coming... Where are we? There we go. I think I have it coming a little too far down, scooping out here at the bottom, because it does this in the real aircraft. This is the venting zone for the engine area. Not the exhaust, this is just the cooling vent, so a number of his radiators and stuff that were in here, this is where the airflow would have exhaust out of there for that. The cowling in general is pretty close. I'm not 100% happy with it. There are things that could be done differently. The legs, they're pretty close, but I don't think I have them spread out as much as they should be, and I think this is part in due to how narrow it looks. With the longer windshield, so I think it's throwing me off on how they should look. Also, the reference imagery that I have for this, I have a lot of images from before he did the suspension, and I think they widened out just a little bit from when he did the suspension upgrade. I'm not 100% sure on that, but from what I can tell in the measurements I can pull off certain drawings, there was about a 5% increase in the distance between here and here. So I'm not 100% sure. But she has legs now, and it's starting to really look like the Draco. I'm quite happy with it. It's getting there. I'm going to keep like tweaking and playing with these fuselage sections. The tail, I still have to come in. Oh, by the way, I made the rudder. Hi, rudder. So I still need to come in and change the shape of the vertical stabilizer for the rudder so that they blend together. And what else? I adjusted the thickness of that curve, so now it looks a lot closer, but I need to now create a sloping curve from the front edge to that so that it all has a nice aerofoil shape, because at the moment that is a flat surface, and that's not what we want. I've got to make a heap of tweaks to the main fuselage shape. I'm going to change a whole bunch of stuff to that, which means I'm going to have to change stuff to this and to this because they all blend to it, and these objects are created from this object, so changing this means that these aren't going to fit anymore, and I'm going to have to do it again, and it's just going to drive me mad. So this is going to take a while. This is going to be the slow and difficult part of this project, is doing all these little tweaks to the general shape of the thing until it looks right. It's a lot of going back and forth, redoing stuff, and then when you change one thing, you have to change another thing because they're touching and they have to blend. And, oh my god. But I'll get through it. It's fine. It's fine. I'll do it. It's alright. Yep. So, yeah, bit of a weird episode today, yeah. Hopefully I taught you a thing, you learned a thing, hopefully, I don't know, like, nobody gave me an instruction manual to any of this stuff. You do have to figure it out over years of practice. Hopefully you guys are picking up a few of the things that I'm putting down, and hopefully that helps you guys make better CAD models and more awesome stuff, and yeah, I'm gonna get back to work. I have so much work to do. This model is not, this plane is not going to finish itself. That's the only problem with this kind of work. It doesn't do it itself. One day I can just ask the AI to do it for me, and then yell at the AI for getting it wrong, and then have to do it myself anyways. Yeah. All right, I'm in chaos. Bit of a quick episode 4 for you guys. Hope you learned something. Go to my Patreon, check that out. Go to my Twitter, follow. Hit subscribe, like if you haven't. I've been looking at the metrics for my YouTube channel and like the forum posts I've made. There's like over 1,000 views on one of the forum posts and no subscribers. Like, come on, what's going on? All right, I'm Chaos, and as always, expect the unexpected. I'll see you guys next time. And a special thank you to all my patrons that help support the channel. If you would also like to support the channel, there's a link in the description.